let's take the derivative of the following function. Let's start with question number 1. The first question says, find the derivative of tan x squared plus x. Tan y is equals to tan x squared plus x. Okay, the first step is that we are going to set the inner function equals to a letter. So I'm going to set the inner function equals to u. The inner function is the function inside the bracket. Do you understand? So u is equals to x squared plus x. So having set the inner function equals to the function inside the bracket, I'm going to take the derivative of the inner function. So the derivative of u, which is the u with respect to x, I'm differentiating with respect to what is at the right hand side of the equation. If you see, you can see that the right hand side of the equation has x. So the u over the x is equals to 2x plus 1 using the power and polynomial rule. Now let's if u is equals to x squared plus x, definitely y will be equals to what? Tan u. Do you understand? Because I have set x squared plus x as u. You understand? So y will be equals to what? Tan u. So I have two functions. The first function is the inner function, and the second function is the outer function. You understand? So I've taken the derivative of the inner function. Now let's take the derivative of the outer function. If you differentiate tan u, don't forget that we are going to get the y over the u is equals to sec square u. Do you understand? So now, having taken the derivative of both the inner function and the outer function, the next step is that we are going to multiply their derivative together. Do you understand? So I'm going to have the derivative of y, which is the y over the x, is equals to dy over du. Dy over du is what? Sec square u. So I'm going to have sec square u multiplied by du over the x. Du over the x is what? 2x plus 1. So I'm going to have multiply 2x plus 1. Okay, let's proceed. So therefore dy over the x is equals to sec square u is, okay, sec square u, let me just put it like this, 2x plus 1 multiplied by sec square u. Don't forget that u is what? 2x squared plus x. Do you understand? So therefore I'm going to substitute u as x squared plus x. So sec x squared plus x. So the derivative of y is equals to tan x squared plus x is what? 2x plus 1 multiplied by sec x squared into brackets 2x squared plus 1. So this is the derivative of y is equals to tan x squared plus x. Now let's proceed to the second question. We have find the derivative of cos 4x squared minus 2x. The first step is that we are going to set the inner function equals to a letter. In this case, I choose u. So I'm going to set u is equals to the inner function. The inner function is the function inside the bracket. So I'm going to have u is equals to 4x squared minus 2x. So having set the inner function equals to the function inside the bracket, the next step is that I'm going to take the derivative of the inner function. So the u with respect to what is here, that is x. The u over the x is equals to differentiate 4x squared minus 2x using the polynomial rule. We are going to get 8x minus 2. So if u is equals to 4x squared minus 2x, then y will be equals to cos u. Because I have set u is equals to this. Definitely y will be equals to what? Cos u. Do you understand? So let's proceed. So let's take the derivative of y with respect to u. So I'm going to have dy over the u is equals to, don't forget, in our previous class we've learned that if we differentiate sine x, we are going to get cos x. If you differentiate cos x, we are going to get sine minus sine x. So if you differentiate sine u, you are going to get cos u. If you differentiate cos u, you are going to get minus sine u. You understand? So let's proceed. Dy over du is equals to minus sine u. So having differentiated both the inner function and the outer function, the next step is that we're going to multiply the derivative of the inner function and the outer function. So let's proceed. Dy over the x is equals to dy over du. Dy over du is what? Minus sine u. So I'm going to have minus sine u multiplied by du over the x. the u over dx is 8x minus 1. 8x minus 1. This is it. This is the formula I'm using. This is the formula for chain rule. Do you understand? So let's proceed. Therefore, dy over dx is equals to minus sine u 8x minus 1 multiplied by minus sine u. U is what? 4x squared minus 2x. So instead of writing u, I'm going to substitute it as 4x squared minus 2x. So I'm going to have minus, 4x squared minus 2x. Therefore, the derivative of y is equals to cos 4x squared minus 2x is what? 8x minus 1 into bracket minus sine 4x squared minus 2. Question number 3. Find the derivative of y is equals to tan x raised to the power of 3. Don't forget the approach. The first step is that we are going to set the inner function equals to the function inside the bracket. So in that case, u is equals to tan x. So the next step is that we are going to take the derivative of u. Now differentiate u. We are going to have the u over the x is equals to sec square x. So I've taken the derivative of u. The next step is that if u is equals to tan x, y will be equals to what? U raised to the power of 3. Because I have set u is equals to tan x, definitely y will be equals to u raised to the power of 3. Do you understand? Where u is what? Tan x. Do you understand? So now the next step is that I'm going to take the derivative of u with respect to I'm going to take the derivative of y with respect to u. So I'm going to have dy over du is equals to 3u raised to the power of 2. Can you see now? So now the next step is that I'm going to multiply both the derivative of the inner function, which is u, and the outer function, which is what? Y is equals to u raised to the power of 3. So I'm going to have dy all over dx is equals to dy over du. Dy over du is what? 3u raised to the power of 3. So I'm going to have 3u raised to the power of 3 multiplied by du over dx. Du over dx is sec square x. So multiply by sec square x. So dy over dx is equals to sec square x multiplied by, let me just put it in bracket, okay? Sec square x multiplied by 3u, 3 into bracket, u is what? Tan x. So I'm going to substitute it as u, tan x raised to the power of 2. So the derivative of y is equals to tan x raised to the power of 3 is what? Sec square x multiplied by 3 tan x raised to the power of 3. Do you understand? So anytime you are asked to differentiate a function that is a function of a function, that is a function that has another function in itself, you make use of chain rule. The first step is that you are going to set the inner function equals to a letter. After that, you are going to take the derivative of the inner function. After that, you are going to set the outer function equals to the function of the inner letter. The function of the inner function. Are you getting it? That's what I did here. I first set u is equals to the inner function. After that, I take the derivative of u. Then I proceed to set y is equals to u raised to the power of 3. Then I take the derivative of y with respect to u. Then I multiply the derivative together. That's it. Take the derivative of both the inner function and the outer function. Then multiply this derivative together. That is what chain rules talk about. Do you understand? That is the summary of what we have been discussing so far. Now let us proceed to question number 4. Find the derivative of y is equals to ln x. This is one of the standard derivative. Now let's break it down. The first step is that we can rewrite this as this. E raised to the power of y is equals to e raised to the power of ln x. Do you understand? We want to eliminate the natural log. Are you getting what I'm saying? So, and don't forget, from your basic mathematics, e raised to the power of ln u is equals to what? U. Do you understand? So let us proceed with this. So therefore, e raised to the power of y is equals to what? X. Do you understand? So for this, I can call this equation 1. Okay, now the next step is that I'm going to take the derivative of both sides with respect to x. So for this, I'm going to have the in y over dx is equals to dx, which is this x, dx all over dx, because I'm taking the derivative of both sides with respect to x. So therefore, the in y, I'm going to have in y dy over dx is equals to 1. Do you understand? Anytime in implicit differentiation, anytime we differentiate in y, we add dy dx. Though I've not taught you that, we are going to progress to it. We are going to proceed to it in our next class. Okay, so just pay attention and listen to it. This anytime you differentiate y, we are going to have dy dx. Let me represent it as derivative of y. This sign also means dy dx. You understand? This sign that I put here, that is y raised to the power of I, means dy dx. Okay, now let us proceed. The next step is that I'm going to substitute in y as x. Don't forget, from equation 1, in y is equals to what? X. So I'm going to have x dy over dx is equals to 1. Therefore, dy over dx is equals to, divide both sides by x. Then I'm going to have over x over x. This x will cancel this x. Is that not it? I just showed this step so that you are going to understand how I got 1 over x as dy dx. Do you understand? So this x will cancel this x. I'm going to have 1 over x at the right hand side of this expression. So the dy dx is what? 1 over x. So this is one of the standard derivatives. It is a very, very important that you do not forget it, okay? So we've learned how to differentiate a function using the various rule and the condition that must be met before we can use this rule. This rule include the polynomial rule, the product rule, the first principle, the chain rule, and the quotient rule. Now, in our next class, we are going to learn how to differentiate a logarithmic function. That is logarithmic differentiation. So stay tuned on this channel. See you in the next class.